Okay, yeah, welcome. Hello, hello. Welcome to week four. Uh, the final week. It's gone very quickly, but we're going to try unpacking lots this week. So yeah, plenty for us to get through, plenty of things for you to learn. So we finished here, I think. We were talking about NFTs last week, and we spoke about compressed NFTs as a way to reduce the costs, particularly for something like an airdrop. And yeah, so I think that was as far as we got. So we can start talking about security now. Okay. Yeah. Um, so security. So there was an attack that is quite a nice illustration of some of the aspects of Solana security. And this was from this involved a project called Wormhole, who they're a very big project. They build bridges between chains, so many different ones. Um, and this particular one involved it was a bridge between Solana and Ethereum. The basic concept the basic concept of a bridge is that in the simplest forms, you have a chain. We've got it here, chain A. You want to effectively transfer a token onto a chain B. So these are typically what bridges do as a sort of very simple mechanism. And the way that that can be done is that you can burn some tokens on chain A and then mint some tokens on chain B, and then that sort of represents the kind of the movement of tokens. So you'll burn them for a particular address on chain A and then mint them for that address on chain B, or whatever the equivalent is on chain B. Of course, for this to work, then there has to be a lot of, well, coordination and security around this. You don't want, well, at one point it has to be, you want it to be atomic. You don't want to get into a kind of intermediate situation where you've burnt some tokens on chain A, but they haven't been minted on chain B, or the process has stopped for whatever reason. Certainly that's something you want to avoid. You also need a lot of security around the fact that you're going to be minting on chain B. So that has to be triggered by the the fact that the tokens have been burnt on chain A. Uh, Actually, it's not doesn't have to be burning on chain A. It could also be just depositing into a contract, but it has to respond to the correct action on chain A before it allows the minting on chain B. But that's just the general idea behind a bridge. Um, so yeah, they have smart contracts on either side, um, and the process that looks after this. There's going to be something in the middle that is checking the different sides of the process of the bridge and doing the burning and the minting and hopefully doing that correctly. And that was what would happen with Wormhole. We had a set of guardians that were there to check that the correct things had been burnt on one side and then minted on the other. It does involve, or it does end up being something like an escrow service. So you will end up with, sorry, they shouldn't say Russian there, I should say ratio. You end up with, yeah, a ratio of the tokens. You're meant to be keeping the correct ratio between the tokens on each side there. Okay. So what actually happened? Well, what the attacker managed to do was to make it look as if quite a large amount of ETH had been deposited on the Ethereum side, and then that allowed the minting on the Solana side of this wormhole ETH. So that was the equivalent token on the Solana side. Um, so yeah, that's kind of I mean a very obvious thing to want to be able to do, but also very obvious that your security should stop that. The response to that was fairly uh, typical. With vulnerabilities and with exploits, we've seen over the years a fairly sort of standard way that they are responded to. It's very common now that if an exploit happens on a particular chain, then the project that has been exploited will often reach out to the attacker and try to come to some arrangement with them, usually offering to give them a bounty if they will return the funds that they have stolen. So, they may say, well, if you give us, if you return the funds, then we will give you, 10% or whatever it is. But this has become increasingly common that they would reach out to the attacker to do that. And this is what happened in this case. As you can see there was the message um, offering them a bug bounty effectively, and of $10 million, and uh, asking for the wormhole ETH to be returned. But they didn't do that, and instead they just kept what they had. It has so this is if I can get the link to work, hopefully. Uh, the it was kept. It has the story has changed as well, so it hasn't. It's not still in this wallet, but this is the wallet anyway that um, of the attacker as well. So you can see the current balance there. Okay. Anyway, so. Um, One point about exploits in general when they happen is that they often have a knock-on effect. They can be quite damaging to the ecosystem as a whole, not just in terms of reputation, but in because of the fact that they may reduce liquidity in a particular token. They may change the price of a token very quickly, and then that can have a knock-on effect, especially with things like borrowing protocols where there may be liquidation events happening, and that can sort of spread throughout the whole ecosystem. It can become quite bad. In this case, something quite remarkable happened where a fund, Jump Crypto, replaced the amount that had been stolen by the attacker. So to try to stabilize the ecosystem, which, yeah, it's amazing that they could do that. But that did, I'm sure that did help. That did, as a practical thing, it restored restored tokens, so that uh, meant that there was liquidity available. Uh, it also then helped with confidence, I guess, and reputation, etc. So that was pretty big thing. So that's the story of what happened kind of immediately. But how did the attacker manage to get away with this? Well, so the basic process, as I said, was the fact that these guardians are there. They are checking that the some funds have been burnt on one side, and then uh, showing that that's okay, and showing that the minting is okay on the other side. And what they do is to sign messages to show that this has happened. And in this case, they there was a function which would be called when uh, the which way around is this? Yeah, the gets called when they want to mint on the Solana side. So this is where what the attacker was hoping to get. Uh, that function has a message which needs to be signed by the Guardian to say what is going to be minted and how much. So this is the thing that the attacker wanted to happen. They wanted this function to be called, and they wanted to fool this function into thinking that some ETH had been burnt on the Ethereum side. So how do they do this? Well, the message itself that is going to be signed by the Guardian is, yeah, some details about it here. But those signatures, those guardians that are checking to see that things have been burnt on one side, and will then sign messages. the function has to be able to check those signatures. It has to know that those are valid signatures from the guardians, and not from someone else, etc. That yeah, that they are valid. So that's the idea behind the verification on that side. They need to be able to check the signatures. So we need this verify signatures function, and that's going to go through the messages to say and to check that they have been signed by the guardians. Now, in this case, this verify signatures function, which is there to really authenticate what's these messages that are coming in, used a particular instruction, the load instruction at, or sorry, a particular function, the load instruction at, which is meant to be data from a particular account, and it's looking at this particular this sysvar program account. So it's meant to be checking against that. It's meant to be coming from that. But the problem is that the when it's doing this and it's loading an instruction, what actually happened with the way that this was being done was that it wasn't being checked that this was coming from the correct place. And what the attacker was able to do was to create a fake instruction, or an instruction with some fake data, and uh, pretend that it came from the particular program, the sysvar program. But this was never checked. So it was never checked that if that was really where it came from. And what they could do was that they could use things that looked reasonable. They could use previous messages um, with signatures, but these were not being properly checked because the we were not using we were not checking that the instruction we were using came from the correct place. Um, which meant that then the all of the signatures were marked as valid, they're marked as true, even though they weren't. So if you have a look at what was passed into this into the program, this is what was supplied. And you can see the difference with this is what the second one here is what it should have been. So this account 3 here, but sorry, so yeah, the fourth account in this set of accounts should have been sysvar instructions, but it was something crafted by the attacker. Okay, um, and that was that account, the this account here was something that they created themselves earlier on, which was going to be effectively saying, yes, all of these instructions are, sorry, all of these signatures are okay, when in fact they're not. So it is a fairly simple thing that they did. It's not massively complex in terms of an attack, but it goes to show um, how careful you need to be when you are taking data, in this case, taking sets of accounts. And what was happening really, there were assumptions being made. There was an assumption this was the correct account, but it was not being checked. Okay. Now, how did this happen? I mean, there's a little bit more to it because this happened in a particular way, in that it was the this vulnerability, the fact that they were not checking this account, was being fixed, and so there was a commit being made, or a commit had been made, to fix the way that this was processed so that it would check that the account was the correct one, that the program was the correct one. Um, so it was going to change and we get this load instruction at checked instead. But this appeared in the repo, but then they hadn't had time to deploy it before it was exploited. So there's the feeling that maybe the attacker was watching the repo and saw this commit going in and realized that he was fixing a potential problem, but he got in and, worked out what that problem was and how to exploit it before they could actually deploy a new version. And so he got away. Yeah, he managed to do that. So this is the timeline. Um, so this is something that, yeah, so it's a known problem with this load instruction at, which should be a load instruction at checked. And but yeah, the new version didn't get there in time. And I suppose this is true generally that the attackers will be there looking to exploit things. If something is known as a vulnerability, then people will try to exploit it. And similarly, if an attack happens exploiting some vulnerability, you will often get copycat attacks as well happening after that to try to do that also. Okay. When this happened, there's just a point here about bridges. It it did bring up the question about security of bridges, that they are, the chains on each side are relatively secure. It's not easy to directly exploit the protocols. They are much more secure. The bridge itself tends to be less secure than that. Um, and so, yeah, it's not a good. Well, what Vitalik says, if you've got some funds in there, then they're less secure than if they're actually held on the chains themselves. So, yeah, it did bring to it did uh, prompt people to question about bridges and are they secure. But I don't think it's changed people's appetite for bridges. And we do need bridges between chains, and people are still building them. So it's just we have to be very careful about the security there. Now the next one is, I don't know how you want to look at this exactly, whether you will see this as an exploit or not. It it could be seen as just clever trading, I guess, or yeah, sharp trading practices. Um, but it's a quite a common type of exploit. You do tend to see similar things, um, which are exploits based on sort of economic factors. So it may not be that there is a particular code issue, as in the wormhole attack. But it could be that the ecosystem and the economics behind particular projects make certain projects vulnerable. So what happened here was that the a large amount of funds uh, were deposited into the Mango markets, and they they use that to then take out a particular position with these tokens, Mango to perp, um, and the the attacker managed to move the price very markedly. So you can see that the price of Mango moved from 3 cents to 91 cents. So the fact that they were able to, well, they were able to move a large amount into this project and into a particular area that was very vulnerable. And with because they'd managed to move the position, then that meant that they had effectively a large amount of collateral, and then they could use that to borrow very heavily and effectively get a lot of borrow a very, very large amount. And that effectively reduced the liquidity then in lending pools because they were saying they had all this collateral, um, and they could just drain lots of pools because they potentially had that much. Okay, um, so. the reason that they were able to do this and move the price so much was because of the fact that there was low liquidity um, in for this particular token. And yeah, they perhaps at one time said this was a failure with oracles, but yeah, they later said it was just manipulating price. But again, you can see here the fact that this happened, the fact that they could move the price, then had an effect because it made a lot of liquidations happen in the ecosystem as well. So it had quite a large effect. But what this meant then was that they were left with very little liquidity, and the hacker or the attacker, they then put in a proposal sort of via governance to suggest that the mango markets should not pursue them, and they should give them a bounty, which is yeah quite interesting way of doing it. I guess in this case they hadn't mango markets hadn't done that directly, so the attacker then put in a proposal for that. Um, as is often the case, people had thought about this problem, the fact that this, maybe something was vulnerable because of the very low liquidity that was there. And um, we often see this. I don't know whether it's just from hindsight that people find, they find out someone who's warned about it previously, or whether it's just that there are people out there warning, but they are being ignored. I don't know. But yeah, some concerns had been raised earlier about this. Um, there are ways that you can try to prevent things like this, although if you are you have to really change the way that the trading is happening, I guess, to do that. If if it's something that's more directly uh, involving oracles and prices, then you can do things such as trying to prevent large spikes having a problem by doing a price that is averaged over time. So that is quite a common thing that people do. So maybe with a lending protocol, rather than taking a spot price, you perhaps would do a price that is averaged over time, in which case something like this, where the price moves very rapidly, would have less effect. So the they wouldn't have perhaps been able to borrow so much in this case because the price would have been averaged over a larger time. But yeah, it's difficult to know how to whether it's possible to guard against these things, or whether it's even desirable, or whether this is just normal trading, and we should just accept that that's part of the DeFi ecosystem. I don't know. I'd be interested to hear your thoughts about that. So yeah, whether you see that as an attack or not. Um, Other thing, another a very 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 worrying attack that happened well reasonably recently was an NPM package being compromised, and you do see these things occasionally. I mean, this is not a Web3 problem in itself. It's just a general security problem that people can do this, the supply chain attacks. But the fact is that they managed to put in a this special function into some versions of this the Web3.js library. And what it was intended to do then was to steal people's keys. So if you were using this version of the package, you could potentially have your keys stolen. Um, and then the the library would send these off to a control server. Um, yeah. So yeah, very very traditional kind of attack going on there. The way they managed to compromise the library was by an email being sent to one of the developers, and then getting details from them there. Uh, so it was available. Oh, sorry, this exploit was around for about 5 hours before being detected. So yeah, not good. Um, but yeah, luckily people did work it out. Um, oh, sorry, the formatting has gone wrong with those numbers there. I guess that's trying to say is, the amount lost is thought to be about, yeah, $1 to $200,000. Uh, Um, yeah, so you have to be careful about malicious packages. Um, Another example here, that targeting developers, because I guess it's quite a lucrative, potentially lucrative, very lucrative target. And so do be careful when you're using or when you're adding dependencies, making sure that they are the correct ones and that you're not picking up something that is potentially malicious. Um, One of the yeah, I mean, one of the most famous groups that does this sort of thing, the Lazarus Group, is yeah, continually doing this and continually trying to steal funds, not just on Solana but across many chains. Um, so it is something that it is to be, yeah. There's a lot of concern about it, and I think quite rightly so. I did see a talk generally about security and some of the different types of attackers and the message from that really was that some of them are, such as the Lazarus Group, are so good that if you're targeted by them, you're going to have a very difficult time. Yeah, they're very good at their job indeed. So be careful, I guess. Yeah. Okay, let me move on. So what can we do about sorry, I'm just going to get rid of that thing on the let me just reshare my screen. Get rid of that. Okay. So what can we do to try to prevent attacks or mitigate attacks as well. So I'm just going to go through some general security guidelines, best practices, to give you some idea of the things we can do. One point, well, this is a very general point, is the open source versus closed source. And I think the consensus is that open source tends to be a better approach in terms of security because there are going to be more people who will be able to see your code and advise you if there are problems. The idea of security through obscurity, by keeping things closed source, I think is not, yeah, is discouraged generally. Um, But yeah, I guess you'll have to decide that for yourself. But typically, open source projects have a lot of people looking at them, and there are a lot of white hat hackers out there that will tell you if there are problems with an open source project. So generally, I think that's a better approach. Then what else can you do? Well, someone just asked, I see in Solana, someone asked about this, about audits. And yes, definitely your code should be audited. This should be part of the your development life cycle. So once you've developed your product, you've tested it, the final thing before it goes into production should be getting it audited. And this will give you an idea of any risks involved. Also, if there are general improvements in your code, it doesn't have to, it's not just going to be security issues that an audit will pick up. It could point you to maybe better design, or optimization, better performance. Uh, the It definitely helps with credibility and uh, new projects, startups that are that are launching will certainly benefit if they can show that their code has been audited. And um, yeah, funding funders will often be expecting that to happen. So that yeah, certainly helps credibility. Also, maybe compliance. Perhaps I guess this is more with larger companies. They may have rules that will expect code to be audited before it is released anyway. Um, so yeah, that's kind of at the end of the development process. Before then, there's just the usual good practices that you've learnt in Web 2 or whatever before you move to Web 3 still apply. So yeah, unit testing, whatever version of whatever approach you want to take, whether you like test-driven development or business-driven development or whatever, all of those good practices still apply when you're developing on Web3 as well. Um, Once you've got your project deployed, that's not the end of the story. So certainly you should be monitoring what is happening, and that will allow you to respond to unusual situations. There are projects generally in Web3 that may help with that. Well, there's certainly tools to help with monitoring, but also there are projects that are monitoring the ecosystem and looking out for odd things that are happening, and trying to detect exploits before they actually steal funds or whatever it is they're doing. So it's worthwhile thinking about that and thinking about what you can do if your project is attacked. How can you mitigate that? What is your response going to be? What can you do? How can you recover funds, etc. And that's going to depend upon having some monitoring going on. You should certainly be learning from exploits as well. So, if there are projects that are exploited, or there are known vulnerabilities, then learn from that. Because, as I said, there will be copycat attacks. So, if another project gets exploited and you've got a similar vulnerability, you should get your code fixed as soon as you can, of course. And then bug bounties. It's good to get the community involved, looking for problems. There are different ways to do that. There are sort of traditional bug bounties that you can do, and the companies that can organize that. Also, what's been happening in the last few years are things like audit competitions, where you put out your code to be audited by the community, and you give prizes for any vulnerabilities that they find there. So there are different ways to do that. Of course, if you're going to do that, then please, make the bounties realistic. What you're with a bug bounty, what you're effectively doing is saying to people, we'll pay you if you tell us about the bug, rather than you exploiting that. And so make it worth their while to make that decision to tell you about the problem rather than exploiting the problem. So yeah, if you are going to offer a bug bounty, make it something realistic. And there are other ways to get involved. Yeah, the white hats. There are groups out there who are either, as I say, there are some groups which are looking for sort of odd situations in the network and sort of trying to detect attacks before they actually steal the funds. But also there are white hat groups as well who are trying to help out projects that have suffered attacks. So you can get involved in those. Um, and also there's, yeah, definitely grant programs around security that you can investigate also. So yeah, just to go through some specifics about this as well in terms of Solana. The the programs themselves are stateless, so that means that we have to provide all the data that's needed. And yeah, if you think about it, then the attacker, that's how they can attack your code. They can provide data to the program that is has been specially crafted by them to be malicious in some way. And what that data is uh, instructions, um, and then also accounts. I guess the other thing is the thinking back to the entry point, you've got the program ID, uh, which does get checked anyway. So if someone's going to attack your program, these are the two things that they can change to try to attack it. And the one of the ways that that can be done is to uh, try to exploit any assumptions that have been made about the accounts that have been passed to your program. Um, so as we saw with the wormhole attack, the they were they were assuming that a particular account was the CISFAR program, but it wasn't, and that's how the attacker managed to exploit that particular piece of code. So thinking about the what assumptions are being made about the accounts is can be very useful, and really you should try to have as few assumptions as possible. We saw earlier, I know I've spoken earlier about the point that with the native Rust implementations, if you are using an iterator to go through accounts, you have to be careful that of the assumptions you're making about those accounts and the ordering of those accounts, because it's very easy to change the order of the accounts being passed in to your program. So do check that. Um, oh, I think we've got a missing image there. I'm sorry about that. The advice was it was just about the fact it was just about some types of accounts, and you have to be careful about those. It was kind of that was the I think he was saying something like that's the one piece of advice that developers should have is to check the accounts that they are getting. Um, So, what could be done? Well, we did see this a little bit earlier when I was talking about accounts, and I was saying that within your program, there will be manipulation of the accounts. We will be looking at the data area of the account and the structure of that. So, if you have an account, when you get your account in, and you're going to uh, do something, you want to manipulate that data. Obviously, if the structure is wrong, then that's going to throw an error. So we're not really talking about that. What we're talking about is where there are uh, maybe two accounts that have the same structure, so that they could be confused with each other, and that they potentially they you could be overwriting data in an account that is the wrong account. Um, and of course, the fact that they've got a similar structure may not be accidental. The attacker could have crafted an account in to be identical to the correct account. So yeah, don't just assume that if the wrong account comes in, that's going to automatically throw an error because the structure is wrong, because it could be specifically crafted to look the same as the correct account. So what can we do about that? Well, of course, the very basic thing you can do is to check the ownership of an account and check that that is equal to the program ID. But that's just the beginning. Of course, uh, you should also be checking, for example, if you think something is owned by the SBL program, you need to check against that is the correct owner. So that's a very basic check. Other checks we should be making also are around authorities. We mentioned this earlier, where I was saying that you're not just going to be checking that maybe an account is the correct one, or just owned by the program. You also need to be thinking about the person who is initiating this transaction, is trying to update that account, or is trying to get the program to update that account and whether they're authorized to do so. So there should be some checks in your code as well around the authorization as well. Um, so this is the idea of, maybe you would have an additional field to show that a particular address is then allowed to change this data, even though at a sort of system level, then the program is going to be able to do that. But then you would want also a different or an additional check to say, well, not just anybody can ask the program to change this data. It's got to be a specific person. It's got to be a specific role. Okay. Um, so this is coming here. So we can check the account is owned by the program. That's a very basic thing. Um, we also need to check that the this was initiated by the the correct person. But then to do that, you need to know that that has been signed for as well. Um, in case that is, yeah, you need to have the signature being checked there. Um, and then the idea I was mentioning earlier as well, generally, is the point about accounts being substituted for each other, or there being some confusion, this type confusion. You can see this in this example where we have uh, two accounts, a funder and an admin account, and they both have the same structure. And it's not unusual, I guess. You're going to have very similar structures in data structures in your account, so it's not unrealistic to think that you would get that. But what an attacker could do is to try to mix up these two accounts and thereby get extra privileges because uh, the admin account is saying, well, this admin key that whoever is that is has special privileges, and the program is going to give them special privileges, and we're going to be checking this admin key against the address of the person starting the transaction. But in doing that check, if instead of looking at this account, we're looking at this account, then obviously this is very different. We're potentially giving special privileges, but this is just a funder. They shouldn't necessarily have special privileges, but that could be done by somebody just confusing these two accounts by sending an account in the incorrect order, so that instead of checking the correct key that we have here, it gets checked against the funder key there, which possibly that could just be easily added to by a user. Maybe anybody could add themselves as a funder. Um, so in with this type of thing, this wouldn't be picked up by just saying, well, is that account owned by the program? Well, yeah, both accounts could be owned by the program. Um, and then we're doing the check to say, do they have special privileges? And that check is failing or not being picked up because it looks as if they are the correct person. And also that could be signed for as well. You could send in the funder account masquerading as the admin account, and you could be signing for that. And it would look okay, but that's not sufficient. So what you need is to know which account you're dealing with. And that's one of the things that Anchor will do nicely for us, because it adds this special discriminator to the account, so that when you're dealing with an account and you're using that data, you know which account it actually is. Okay. Um, yeah. So that's going through some of the potential problems, but hopefully that will give you an idea of what you need to think about when you're using accounts. And it hopefully illustrates that there are a number of things that you need to look out for. You can't just check that the account is owned by the program, for example, you've really got to go into and check a number of things. So be aware of that. But if you're using Anchor, then that does make the whole thing easier because that will help you check that the account is the correct one. It also prevents it, yeah, being initialized twice, which also could be a problem. What else could go wrong? Well, yeah, there's all sorts of problems that are quite general. I mean, things like overflow with arithmetic can happen as well. It's which is not a Web3 thing particularly, but you do need to be careful about that. Also, um, there are libraries to help you with that. One of the common problems in general insecurity in the Web3 space is around precision of operations as well. You need to be very careful that, particularly if you're looking at, say, prices in DeFi projects, you have to be very careful around the precision of the values, and that if you start to lose precision, then that potentially opens up the project to economic attacks. For example, things like price manipulation. Yeah. Okay. Um, oh yeah, this is just the things that you can use to check libraries you can use to check that arithmetic is being done correctly, or you can set special values, the saturation there. Um, Reentrancy, this is something that very big in the Ethereum, maybe in Solana. Um, but you do need it kind of reentrancy is a well, it's not exactly no, it's not currency problem because like we don't exactly have that on Ethereum, but you do need to think about those types of things. What happens if the a function is called repeatedly? And yeah, is it possible, for example, to have stale data involved that could mislead your users, all those sort of things. So not a classic reentrancy as such, but sort of expanding that a little further and looking at how those sort of things could happen in Solana. Then you get to things like, yeah, what can happen if you're repeatedly um, calling functions. Okay. Um, This is I've got here some notes of common problems. I think I've actually just gone through all of those, but yeah, there's a blog post there if you want to have a look. And this is showing an example of one of those attacks that I meant, or one of the areas that could be attacked that I mentioned earlier. The fact that you need to check, excuse me, that someone has signed for an account. So this bit here that is commented out is the check that you should be doing to make sure that somebody is a signer. Yeah. So, but have a look at the blog as well. That'll explain things well to for you. Um, this example here around initialization. This yeah, when you're doing initialization, you do need to have thought through should that be able should you be able to do that again? Generally, it could be that you would want to initialize things a number of times, but often that's not going to be the case. So if you don't, then you need ways to prevent that. So whatever the situation is, in your particular context, then you do need to have thought through, uh, can this can things be initialized twice? If If not, then what are you going to do to prevent that? And Anchor does help with that as well. So um, yeah, you can see there. It's doing a check to show that the discriminator hasn't been set, so that's to prevent it. Okay. Do have a look at I did give you a list, or a link to the list of uh, the the macros that you can use in Anchor. There's lots of useful things there, so do have a look through those. That could be helpful. Um, Other things, I'll just explain this fairly briefly, but the uh, people can do denial of service or sort of griefing attacks, I guess, by trying to stop some process completing by causing it to run out of gas. So be aware of that. Again, this is more of a Web3 problem, the fact that we have limited resources and we use gas as a way to prevent some types of problems. But then also the fact that we're using that or the compute budget does mean that people can do malicious things and try to cause valid functions to or valid transactions to fail. So do think about how people might do that. Numerical precision errors I've mentioned already, especially important with prices in DeFi. Part of that could be around truncation as well. If you're casting between different data types, then be careful in case you're truncating something important there. Oracle manipulation. We'll talk about oracles in a moment, actually, but so yeah, hopefully you will have found oracles that can be relied upon and don't just look at a single source. Also, if you are using a source of a price source, for example, uh, think about how that price source could be manipulated. If you, for example, are looking at the price on an exchange for a particular token, then someone could manipulate that price by doing a large trade on that exchange, which then may cause your project problems because that if you're using that as your oracle. So think about that. The vampire attacks, these are around, really, this is taking liquidity. I'm not sure that's more nebulous, I guess, but that's more to do with your application design generally, and the business logic. I'm not sure what you can do much about. I don't know if you can do much about that. Um, Denial of service, of course, yeah. Yeah, that happened. I think that's maybe perhaps that's easy. Denial of service may be easier on Web3. I don't know, but yeah, maybe. Timestamp dependence. Although um, Solana is better than other chains, I suppose, at handling times, you'd still need to be careful about if you are using times and you have a dependence upon a time that is produced by validators, then do be aware that that could be done, they could be doing something malicious, or just being inaccurate to some extent. So it's still an area that you should be aware of, even though that Solana does that better than most chains. Yeah, the cross-function reentrancy, this is just the idea that you you could get stale data effectively in with function calls. So be aware of that. And economic attacks, we've kind of shown that. Um, Here's some examples of problems of bad practices, so where things have gone wrong. So have a look through those. The We've kind of looked at the arbitrary programs being passed. Um, I don't know if you want to go through all of these. Maybe I'll just leave the things for you to have a look at yourself. But if you want to ask about them, then please do. We've spoken about these last few here as well today. Um, yeah, so do check that out. Um, yeah, this I think these are all just guides as well for to more examples. I saw the format has gone a little bit wrong there. Um, yeah, I think these are all ones that we've considered. Um, let me just check this one because I think this is, yeah. So lots of resources there for you. That's probably a good one, I think, to a good place to start around. If you're interested in on the security side, that's probably a good place to start as well. Um, and then that's more, I suppose that the focus for what I've just been talking about was more on the application side and looking for problems in programs. Uh, but also, you do, obviously we could suffer if there are problems in the protocol itself. And so Solana offer bounties for if you find problems. So yeah, just to give you an idea, obviously these bounties are relatively large because they could be quite devastating. They could have quite a large impact if they uh, are exploited. So yeah, if you're interested, you can check those out as well. I These things are going to be quite hard to find though, to find bugs in these areas. But obviously, if you do find them, that's very lucrative. Uh, and then particular projects also will provide bug bounties. So there's just an example here from Mango Markets. I'll just say as well, the advice applies to bug bounties, but it also applies to audit competitions. If you're taking part, do read the criteria very carefully when you are submitting problems because they will apply it very strictly. And so think about that before you spend time, building a proof of concept, for example, just to make sure it is something that is will be accepted uh, by the whatever project it is. Um, yeah. So but they will provide, these guidelines, but you have to make sure you follow them exactly. Okay. All right. So that was a little bit about security. So I'll turn on to a project that I won't go through all this in a lot of detail. There's quite a lot of uh, words there for you to read through. But it's an area that did become very popular. I get the impression that this is less popular now. This area generally is less popular than it used to be, but still certainly existing. Um, and I mean, the technological aspects are, a lot of them have been around. If we talk about meme coins, these are the tokens involved are very straightforward. The difference is that they're very much based around whatever types of memes. But they're very specific, very current. They'll be things that change very quickly. And of course, you do get them on lots of different chains. Um, if you are, you probably know the memes better than I do, but yeah, we do have a lot of memes in Web3 generally, and that I suppose provides quite a rich area to exploit there. Um, and the culture around Web3. Um, One point though, meme coins, I mean, they have very little intrinsic value. They are not they're not intended to have that. They're more around being used for speculation, and maybe just acquisition of the latest whatever the latest meme is. But a lot of the work is involved in them is around the marketing and the promotion of them. Um, Solana, I think, has perhaps uh, facilitated their development more than, or is used for them perhaps more than other chains because of its technical aspects. The fact that you've got uh, high throughput with transactions certainly helps. Although, yeah, they're on other chains as well. I'll talk about Pump.Fun in a second. Um, yeah, this is just to give you an idea of some of the reasons why they may be more prevalent on Solana than some other chains. I think things like the transaction, well, that should be throughput really, I suppose. Um, and the low fees do make working with them easier. Um, if you want to create tokens, well, we've gone through this. It's quite straightforward. In some ways, it's maybe more straightforward on Solana because you've got the token program there for you anyway. Although the way that the accounts work is a little bit different, but once you're used to that, then that's all there ready for you. So it's something that you can easily use to create new coins. Um, but as I said, you've got to then think about the marketing. That's going to be a major part of it. Um, there's nothing I think in terms of the on the technical side, there's nothing maybe special about a meme coin. I mean, you can just use the SPL and the token program to create them. Although people are doing, we'll talk about pub.fun in a second as well. But there's nothing that is necessarily different to how you would create other tokens. I think, the difference is perhaps more on the around the marketing and using that. The launching of these. I did mention a little bit about this before, the different ideas around launching things and the idea of fair launch. I will talk about launch pads as well. I know some people are interested in that. If you're interested in the coins, this is just we got some details here of some of the major ones. Um, I know in the last cohort, I did put out a poll about meme coins and people's attitude, which there seemed to be a change, I think, uh, towards in people's attitudes towards meme coins. I think they're becoming less popular overall. Uh, the risks involved, I think, I'm sure we know these fairly well. The fact that there is uh, a large, potentially very high volatility associated with them, which in many ways, so that's really the point of them. The fact that there is a huge volatility, the fact that you can speculate on them. So that's kind of intrinsic to what they are and how they're intended to work. Um, Regulation around them, well, it's generally fragmented regulation generally, and one point with regulation and Web3 has been that the financial regulators tend to come in when when they see things that are perceived as scams or particularly risky. So this this may trigger regulators generally if you've got things that are potentially very speculative, very high volatility, may be seen as being a scam by people. That may bring in interest from the regulators, and they may try to try to regulate. Although how they can do that, is questionable. The regulation tends to work where the Web3 world and the traditional finance world meet. That tends to be where it can be done most effectively. So it's not something you can necessarily stop people creating these things. Um, yeah, but that's a little bit about meme coins anyway. Do have a read through of that if you're interested. Which brings me on to pump.fun. Uh, this really was there to make this whole process, the process of creating meme coins, easier. it does have some interesting aspects to it as well, though. It is there to help automate some parts of it. I suppose, as even though I've said, creating a token is relatively easily because the code's already there in the token program. You do need to understand the way that the accounts work, but we've gone through that, and I think you've all tried this out. So it's not difficult. But then, this is for I'm talking to developers here, so for non-developers or people who don't want to get involved in the technical side, then automating all of that does make a lot of sense. So what Pump.Fun allows is just people can provide the basic parameters for a token, and then it will do take care of all that for you. The, there is an advantage, I suppose, in that the program has been audited, so that does mean that potentially there's better security, I suppose, because of that. Um, yeah, and it offers a common token, the stuff the common token standard offers. The way that it works is via the special bonding curves, um, and we spoke about this a little bit, and I did talk about the fact that automatic market makers use a particular type of bonding curve to work out the price in liquidity pools. With Pump.Fund, they have their own curve, which you've got here. Um, they've designed this in a particular way because they want people to get involved early on. So they've designed this to encourage early participation. Um, they also have this point about the locking of liquidity at a certain market capitalization there. Um, so this is a security feature, I suppose. It does try to reduce the possibility of developers suddenly withdrawing all the liquidity. So once you've got a certain amount of value locked in a particular token, then it does get locked, and then for that tries to stop the developers withdrawing all of that. And this is all done in the program itself. So does help with the credibility of this, I suppose. Of course, they're going to charge fees for providing this, which is fairly straightforward. Um, yeah, that's just standard technical stuff. Um, of course, uh, although it's audited, you still need to be careful, of course. Um, the the bonding curves, they're transparent, so you do know how they work, but there can still be price manipulation. The fact that you know what you're getting doesn't mean that there can't be manipulation. So you do still need to be careful about that. And I think the way that this was designed so that early participation is encouraged means that this then is open to manipulation at the early stages. So that's something to be careful about. Um, Centralization, this is depending on Pump.Fund themselves. So there is a centralization aspect to that because you're doing all of this through their programs. So yeah, something to be aware of also. Uh, so are we okay? All right. So let me then quickly move on to oracles. I did mention them generally, and I've moved these in the notes. They were in a later lesson, so I brought them forward a bit just because I wanted to have time to get through more things. But the idea behind an oracle is the fact that with in Web3 we are operating in a restricted environment. We can't uh, go out to get data easily. and also the fact that because we're uh, doing DeFi, we do need reliable sources of information of, for example, of price information. Um, there, as well as the security side, then oracles need to be efficient. They need to, the price needs to be very much up to date. There's no point in getting a price that is a few hours old. You need it to be, yeah, very current. And there are a number of projects around in this space. I guess one of the oldest or most established would be Chainlink. Um, yeah, but there are other ones as well. So I'll just talk through these. Um, yeah, the Pith Oracle network is uh, one of the major ones, I think, and um, it fulfills this point about being up to date by the fact that it can do things very efficiently, it can update the price feeds very quickly, and um, it also, yeah, can provide data across chains as well. What this looks like, if I can show you, um, yeah. So you've got examples here of some of the feeds. I mean, there's lots, as you saw, uh, as you can see, but they're all being updated very quickly, giving you prices. Also, the fact that you get a confidence bound as well to give you an idea of how accurate the information is useful. The integrating this is, I think, reasonably straightforward. You may need to think about two aspects to this as well, in that you may be using the data on chain, but you may also be using it off chain as well, as part of your app. So if it's on chain, then it makes sense that you're going to be reading this from the the program on the chain. Solana in this case. Um, but then if it's off chain, then you can yeah, you can just go and get those updates themselves by using the SDKs. Um, an example here of how you can do that, I think, is it this one? Oh no, sorry. Uh, this one, yeah, this is the an example of what you can do if you want to use Oracle, if you want to build or integrate a price feed in Oracle, sorry, in Anchor, if you want to get it from the Oracle. So yeah, that's an example for you there. So that might provide a reasonable starting point for you. So that's that. Another one, switchboard. There's a link there to some docs as well. Oh, one thing, yeah, I didn't say is that we're not just talking about prices. It's useful to be able to get a source of randomness as well, which is why we have why a lot of oracles will provide uh, random functions that are verifiable. Um, so that's something else if you're doing things like games, particularly, you may need things like that. Okay. Um, as I said, the one of the most established is Chainlink, well known across many uh, many different chains there as well. Um, and this is a comparison. Yeah, you're going to have to know about the data format for the things you're getting. Um, One point, I don't know if I've got notes about this, but there's different types of access that you can do. There's the pull based approach, and there's a push based approach. And uh, with the with the push based approach, I think this is this is maybe the most standard or one of the earliest ways of doing it. the Oracle itself will be pushing data on chain into a particular, I suppose, an account on chain, which can then be used by your program. So that's pushing data, and it will, that is very much the Oracle doing that at a regular interval, but potentially um, that interval may be comparatively large. It may not be able to push it as often as you would like. And that also means, it's not necessarily the most efficient thing. It just pushing this data is not necessarily the most efficient way of doing that because that's not responding to what people want. So another way to do it is the idea of the pull-based approach. For example, you got there with the data streams, where you have a mechanism so that you can flag your interest in some data, and then that will get provided by them. So, but you have, your DApp has to be saying that you want to be accessing data from this data stream. Um, but that makes it, I think the idea is that that makes it more up to date. That increases the accuracy perhaps of the data that you get then. Okay. All right. So that's, yeah, a little bit of detail about oracles. If you want more, then as I said, please do ask about that. Okay. We're almost out of time. Let me just, yeah, I've shown you that. That's that. Um, what we got coming up tomorrow? We talk about the 2022 program, the extensions to the token program. We'll look at some possibilities of interoperability, confidential tokens. Well, that's really also part of the 2022 program. We'll also look at some examples of designs you may find useful for Anchor. Version transactions we can mention. We'll also I'll talk about Solidity if you're interested. I it can be useful, I suppose, if you're used to writing in Solidity, but you do need to bear in mind that it's really just a language. You're still using the same sort of programming model. You still have to, think about accounts, etc. It's not that it works in the same way that it would do on the EVM. I've got some details of running a validator as well. As with all of these, I'm moving the topics around a little bit just to try to get as much in as I can. So yeah, thanks. Bye bye.